Well, hello everybody. This is David coming to you from the quarantined land of New Mexico. How are everybody doing? I hope you're staying well, staying safe, um, and that the coronavirus hasn't affected anybody. Um, I'm finally getting to a place where I thought I could record a video. I've been thinking about this for a long time about how computers are designed, and I wanted to make a little video here. Uh, I want to encourage you to ask me questions. If you think we need uh, another video explaining things, let me know. So here we go. What is a computer? Uh, a computer is actually anything that computes. Uh, I watched the movie Hidden Figures. If you haven't seen that, you really need to watch it. It's excellent. Um, and in that movie, they had a bunch of ladies that did calculations uh, for NASA for different things, and those ladies were all called computers because they did computing. So even a person can be a computer. A computer basically takes an input, does something to it, and produces an output. That's all it is. Uh, it can be any kind of input, can be any kind of output, and you can call that a computer. So lots of things basically are computers. Your TV remote, your cell phone, the oxygen sensor in your car. Most cars now come with a computer. They'll tell you uh, if you take it in for service. Uh, they'll tell you about the car's computer. Uh, so, what other things can you think of? Tell me in the comments other things that might surprise you and be computer. Uh, so, for inputs on the one end, you have your keyboard. I have mine here. You might have a graphics tablet. Architects use those a lot. Basically, it's just a square piece of uh, plastic connected to your keyboard by a USB and takes input. Uh, your mouse is an input or a keyboard, an input. Uh, some people have touch screens. If you have a iPad or something like that, it has a touch screen, which is an input. And there can be lots of other things that are inputs to the computer. Uh, then once you input your information, there's sort of a black box. You can think of it as your desktop, your little black box that sits there. Uh, you don't need to know what's going on in there. Uh, Most of you have no idea what's in there, and there's nothing wrong with that because it's just a black box. Uh, in there is your CPU, which is your processor, uh, GPU, which is the graphics processor, your memory, or they call RAM, and then again, there can be all kinds of other stuff in your little black box. Uh, and then once you get through processing, there's output. And nowadays they're just all kinds of output. Your printer, they used to have plotters. I don't think they have those anymore. Your screen can be output. Video, like I'm doing here, can be an output. Uh, you can use serial output, which is RS-232, just two twisted pair. You can use that to drive other devices or to send out information. And again, there's all kinds of output devices. Uh, Let me tell you a little bit about the way computers began. In the top left here, it's really, I think it's funny. IBM ships their first hard drive. Uh, this drive holds 5 megabytes of data. Think about how much that is or how little that is. It has 5 gigabytes or 5 megabytes of data, and it cost $10,000 a megabyte. Uh, think about your telephones now that have 256 gigabytes of memory. Uh, the system, this disk drive, is as big as 2 refrigerators side by side, and it uses 50 24-inch platters. Uh, so uh, that's a pretty huge. Get down. That's a pretty huge disk drive. You can imagine that. This over here on the left, that's a Cray supercomputer. Uh, in the days like in the 80s, Cray supercomputers were the workhorses of computing. Uh, they were so fast and so uh, powerful that you couldn't log in directly to a Cray supercomputer. You logged into a uh, pre-processor, a pre-computer, did all your work, and then submitted your program to the supercomputer, which ran it and then sent back your output. Um, it was so fast that the wiring inside the computer, none of the wires could be longer than 3 feet because it would slow down the processor. Um, so the uh, the wiring inside, no more than 3 feet. Down at the bottom there is a typical, nowadays it would be a parallel processor, but you could imagine this is what a computer room looked like in the 70s and 80s. Uh, just boxes and boxes of computer, had to be water cooled, and this was where everybody uh, logged in and did their computing. Um, and after the supercomputer, they built what was called parallel computing, and basically, I don't know if you guys remember SETI, where lots of uh, laptop and desktop computers around the world all uh, were doing computations for SETI. That's a parallel computer. So this parallel computer had lots and lots and lots of processors, sometimes like 256, and then disk drives and all kinds of things, and they all worked together on a problem. And then over here to the right, I wanted you to see this is what a NASA control center looked like. And yes, all of those video monitors you can see there are monitors. They have keyboards, and they log in to the central computer, which in those days was an IBM, and that central computer connected all of the serial output from the rockets and the lunar lander and things like that. And so the data coming from the lunar lander was all sent over this serial line or serial transmission that was basically very simple. All it sent was just what it could send down a twisted pair. So there were lots and lots of people involved. Mostly each one of those people are responsible for one set of data. It might be temperature data, it might be heartbeats of the astronaut, it could be telemetry, just all kinds of stuff. But each monitor had a purpose and had data that scrolled constantly that they watched. So it would be very hard to fake all of this. And I'm sure you have to admit that all of this that we're looking at here, there are just lots of people involved and trying to invent the data that they're looking at would be virtually impossible. The other thing I want you to notice is that these are terminal screens and keyboards. They're not computers. I've heard some people laughing and talking about how one of the guys had coffee sitting next to his computer and how that was absolutely prohibited in a computer room. And so I had to tell him that those are not computers, they're terminals connected into a mainframe computer. So I also, on the top right here, the lunar lander had a computer that was 1,300 times less powerful than a flip phone. And you remember flip phones from the 2000s. It had 64 kilobytes of RAM. That's not gigabytes or megabytes, that's kilobytes. The clock speed was 0.043 megahertz. So if you look at like when you go to buy a laptop, they'll tell you it's 2 gigahertz or 3 gigahertz. That's huge compared to megahertz. I couldn't find the information on the disk, where it saves to disk, but I can remember them saying that there was a disk drive, but it has to be less than a 120 kilobyte floppy. That's what was on your PC in 1984 when they first came out, 128 kilobytes, and it was a floppy drive, not a hard disk. The NASA budget and evolution of computers. This list I'm showing here at the bottom left is a list, just a very small partial list of the companies that were involved in, and this is only the Saturn V rocket. This is not the lunar lander. This is only companies that helped build the Saturn V. And you can look it up at that address. Just imagine what this overall list is, and the thousands and thousands of people and the states that benefit from NASA's budget. I remember NASA was careful to dole out their budget to differing states to kind of spread the wealth so that different states benefited from that funding. NASA funding was directly responsible in driving the development of smaller, more powerful, and generalized computers. NASA needed the computer to weigh less, to be smaller, to fit in the lunar lander, and so they did that. And so you can imagine over 50 years, hundreds of thousands of people have been involved with these NASA developments, and you can see the output of their developments all around the world. So definitely NASA does not sit and do nothing with their, whatever it is, $52 million a day. Isn't that what Flat always tells us? So my conclusions to all this are, I hope that you've learned just a bit or a bite of how computers work, the myriad of parts that go into making a computer, and the evolution of the machine that pretty much controls our world. I'm sure all of you know how much of our world is controlled by electronics, computers, and such things. So if there are those of you out there that are flat earthers, NASA haters, it's not a secret that a few upper level control and hundreds of thousands of others over 50 years know nothing about. You just have to imagine how in the world 100,000 people can keep a secret for 50 years. If you remember the Clinton-Lewinsky affair, that was two people, and it was only a few months before it was all over the news and out everywhere. And here we have, secrets that are controlled by all kinds of people. So just like gravity, what I'm trying to tell you, just like gravity, let's take a small part of the computer away. So flat earthers believe that gravity doesn't exist. So let's take just a small part of the computer away and say that it never existed. So let's pick apart RAM. So now RAM cannot exist, never existed. Nobody knows what that is. So the entire design of the computer does not work. None of the input can do anything. The black box cannot do any computing or anything like that. And there's no output. The entire design of the computer would have to be replaced by something that performs the function of RAM. So just like gravity, there are things before gravity, there are things after gravity that all uh, um, depend on that one uh, physical law. And so uh, you can't just say it's not there. Uh, you have to have something that performs that function, and it would have to be designed, tested, experimented with, and the specs would have to work somehow in the computer design. Just think about it. Think about how just taking that one small part away, and just like that, in our natural world, in our observations of the world, let's take out gravity and say it doesn't exist. Well, then there are all kinds of things that no longer work. Uh, so these are some things that I want you to think about. Leave me some comments. Tell me how you like it, or uh, what your thoughts are about uh, what a computer consists of, the different things. If you want to see more of this kind of information, I'll be happy to put something together. So you guys let me know, okay? And uh, another thing I just wanted to close with, uh, computers are changing. They're getting smaller and smaller, more and more powerful. Uh, we just don't know what the future holds. And it's going to be an exciting world. You should be thrilled if you're in any part of uh, computing, because it's going to get uh, exciting here just in the near future. Uh, so don't forget that.